talking about how to multiply monomials together. And some of you might be asking yourself, so what in the world is a monomial? So I want you guys to write the word in your journal. Write the word monomial. Okay. Then next to it, I want you guys to write binomial. And then next to that one, I'm not going to believe what I'm going to say next. You're right. I know, it's okay. Now, a monomial, I want you right here. I'm going to highlight the word mono, then bi, then tri. When you think of mono, what do you think of? What number? 1. What about bi? 2. What about tri? 3. So monomials it has one term. Monomial is something that has one term. Binomial has, right, 2 terms. Okay? And trinomials have 3 terms. Okay? Now, let me give you some examples of monomials. A number, just by itself, a coefficient, 4, that's considered to be monomial. If I said 8x, that's actually a monomial. So what do we have to do with the 8 and the x? They're being multiplied together. I could say 8x, y, z. Because technically, what do I have to do with the x, the y, and the z? Multiply it all together. These all are all considered to be how many terms? That's 1 term. That's a term. That's a term. Those are all 1 terms. Okay? Give me an example of what you think would be an example of a monomial. Give me. 45, yes, very good. What if I stuck an a next to it? Is that still okay? Yeah, very good. So that's correct. So these are all considered to be monomials. If I said, ooh, watch this, 45a squared, still 1 number. Binomials, watch this. Would you agree that's a monomial? This is a monomial. But if I put a plus sign, now I don't have 1 term, I have 2 terms. So that's considered to be a binomial. What if I put x minus 5? Binomial. That's a term, that's a term. They're not being multiplied together, they're being added or subtracted. So I can't combine these, can I? Alright? This is where it gets a little bit tricky. Watch this. If I said x plus x, some students might go, oh, that's a binomial, but we can actually combine these like terms to get 2x. So x plus x becomes what? 2x, which is still a monomial. Okay? And what if I said x times x? That's not 2. Nope, it's actually a, nope. It's a monomial. Because what is x times x? X squared, which is still a monomial. Okay? There we go. I'm sorry? If they're stuck right next to each other, that means they're all being multiplied, which means it's just 1 term. Okay? So if you're being multiplied, they're all 1 term. Here, something's being added or subtracted. They have to be different. Well, because that's an x, and that's an x, and these are like terms. How many x's do you see? 2. There's an x. There's it. How about this? You break up with a boyfriend, that's an x. You break up with a boyfriend, that's an x. Together, how many boyfriends have you broken up with? 2. You have 2 x's. Okay? Does that make sense? Alright, there you go. Now, here's another binomial, right? X squared plus y. That would be considered to be a binomial. Now, a trinomial is like saying something like this. Watch. X squared plus x plus 5. A plus B plus C. See how these are all different terms? How many terms do I have? 3. I have 3 different terms. Okay? Now, let me explain something real quick. That's a monomial. That's just by itself, 1 term. But anytime you have 2 or more terms, those together, and any more, like 4 terms, 5 terms, 6 terms, those are all called polynomials. What does the word poly mean? Many, more than. More than what? At least more than 2. Okay, that's right. 2 or more. Poly means 2 or more. Okay? So if somebody is a, by the way, let's think about the real world. If I say somebody is a monotheist, they believe in one God. If I say somebody is a polytheist, they believe in multiple gods. How many? I don't know. A lot. More than one. More than one. Okay? All right? If you ride a bicycle, how many wheels? 2. Okay? A tricycle has 3. So that's kind of how you guys need to understand. Okay? But today, now, let me give you some examples of things that are not monomials. Okay? So by the way, these are all examples of things that are not monomials. So here's some other examples. So here's what I want you to do in your journal. Fit. Not a monomial. Okay? Not a monomial. So I'm going to make a little box here. We're just going to put things in here that are not monomials. Okay? Watch this. I cannot do a 5. Now 5 is a monomial. But if I said 5 divided by x, that's not considered to be a monomial. You're not allowed to have variables in the denominator. They're not considered to be a monomial. So that would be that. Okay, so this is not a monomial. If I said the square root of x, that's not considered to be a monomial. So radicals, by the way, if I, right here, now radical 2 is a monomial, but if I cannot put variables inside of the radical sign. Okay? So another example I said was what? A plus b, that's not considered to be a monomial, that would be considered a polynomial. Okay? So these are all examples of things that aren't considered to be monomials. If I said x to the power of 1/2, that is not considered to be a monomial. By the way, these right here, just so you know, just the same. Bless you. The square root of x and x to the power of 1/2 are the same. That's under a different video dealing with rational exponents and radicals. So what we're going to do now is we're going to take this information, okay? And what are we multiplying right now? We're multiplying simply what? Monomials. We're taking this monomial and we're multiplying it to this monomial. This is what you're going to be doing today. Here we go. What is negative 9? And even though you can't see it, what number is there? There's a 1. So what's negative 9 times 1? Negative 9. Now, I have n to the power of 9 and I have n to the power of 3. When you take n to the power of 9 and you multiply it to n to the power of 3, you're allowed to take those exponents and add them together. And so my final answer is going to be n to the power of 12. And that's what I would type in. See, it says your answer should be a monomial in standard form. This is a monomial in standard form. That would be the answer to this problem. Okay. All right, here we go. Next problem. What we're going to do is right here. This one says, a little bit more, it's a bit harder. It says, multiply monomial. This one's a little bit harder, so we're just going to make it a little bit bigger. W to the power of 5. Z squared. This is negative 9. W squared. Z to the power of 5. So write that down. All right, now, even though you can't see it, what's the coefficient in front of that W? A 1. So what is 1 times a negative 9? Negative 9. What am I allowed to do with this exponent, that 5 and that 2? What am I allowed to do with it? Add them together, you're right. So that's going to be W to the power of 7. And what are we allowed to do with that exponent and that exponent? Add them together. That's the product property. We talked about this. Any final answer? That's what I would type in right there. You're done. All right, now we're going to go on to the next problem right here. Oh my goodness gracious. What I want you guys to do is I want you guys to simply draw this rectangle carefully right now, please. All right, so this says multiply monomials by polynomials, and we're dealing with area. All right. Now, which one of these is the polynomial? The 3x squared plus the 8x plus the 7. Which one is the monomial? 7x squared. Okay? So I'm going to do these in 3 different colors. Okay? We are going to find the area of this, which is what's called the length times the width. Then we're going to find the area of this, and the area of this is the length times the width. All right, and we're going to find the area of the green, which is the, once again, the length times the width. All right, so we're going to start with length times the width of the blue. All right, so what would you call the length of the blue and the width of What's the length of 7x squared? Very good. What's the width of just the blue? 3x squared. Very good. Let's multiply those together. What's 7 times 3? 21. Ooh, what are we allowed to do with those exponents? We're allowed to add them together, and we get x to the power of 4. So what I'd like you to do in this little rectangular box, I'd like you to write 21. Wrong, forget one. X to the power of 4. Now we're going to go to the red. What's the length of this? The length is the same. What is it? 7x squared. Very good. What is the width? 8x. Very good. Let's multiply them together. What's 7 times 8? 56. Okay? Now that's x squared. That's actually x to the first. So 2 plus 1 is, that's x cubed. So this answer is going to be 56x cubed. And last but not least, let's do the green rectangle. What's the length? Once again, it's 7x squared. What's the width? 7. 7 times 7 is 49. 49x squared. So what's this area? 49x squared. So here's my final answer. Alright? I'm going to write down what I'm going to literally type into this area box. What I'm going to type in is this. 21 x to the power of 4 plus 56 x cubed plus 49 x squared. That, right there, is your answer. Yeah. You know what? On this one, I'll actually type it in so you guys know it's the right answer, okay? So I'll go ahead and type it in. Okay? Here we go. 21x to the power of, I got to go down a little bit. Power of 4. And then it was plus 56. And we said x to the power of 3. Okay? And then we said plus. And we said 49. And we said that was x to the power x squared, right? Okay. There we go. There you go. See? It works. All right? So do you guys see how all these are going to be just a little bit different? What are we going to multiply to each of these? C times c squared. What is c times c squared? C what? C cubed, right? What is c times 4c? Yeah. 4c. Very good. 4c squared. 4c. Oh, uh-oh. Oh, bummer. Yep. In case you missed it the first time. All right. Oh, not 65. Plus 49x squared. There we go. All right, here we go. Ready? C to the power of what? C cubed, right? And what did we say the next one was? 4c. Nope. Squared. Because, I don't know, c times c is c squared. That's right. And what's the product of 3 times c? That's right. There we go. And see, that's all you have to do. See how easy that is? And you're done. Okay? All right, let's go to the next one. Okay? All right, next one I want you guys to write down carefully. I'm going to write it down with you right here. All right, I have 8r squared times r squared minus 2. Just like that. So write it out. So what we're going to do right now, we're going to take this 8r squared, okay? And we're going to take that and we're going to distribute it, or we're going to multiply it to r squared, and then we're going to multiply it to the negative 2. So 8r squared times r squared becomes 8r to the power of 4. Because 2 plus 2 is 4. And 8 times a negative 2 is a negative 16. But what's a 16r squared. And that's what I would type in as the polynomial it's standing for. Now what kind of polynomial technically would I call this? This polynomial can also be called a binomial. Okay? Right? Because there's two different terms. That's your answer. Alright, here we go. Last one. Oh my goodness gracious. This is a good one for you guys to write down. So right now, I'm going to go ahead and pause it. I want you guys to write it down. Alright, so here we go. Here's what I have. I have a big old 4y. I'm going to open up a parentheses. I'm going to put in a. I'm going to put y squared minus 7y plus b close parentheses equals. Okay? Now what is that all equal to? I've got a 24y cubed. I've got a minus 28y squared minus 8y. So that's what I have. So I want you to write that out exactly as it appears, except the only thing I'm going to do a little bit different here. Okay? What I'm going to do is I'm going to put a little box around the A, I'm going to put a little box around the B, and I want you to understand that what I'm looking for is I'm looking for a number that I need to plug in here, in this box. I'm looking for a totally different number to plug in here in this box. That's what I'm solving for. I'm solving for what would go there and what would go right there. Now, if I were to distribute, okay, if I were to distribute this 4 to each of these numbers, okay? All right? If I distribute a 4 to each of those numbers, all right? Think about this. 4 times what number would get me to a 24? 4 times what gets me to a 24? 6. 4 times 6. Would you agree? 4y, ready? 4y times 6y squared gives me 24y cubed. Now, why is that important? Because the answer I'm looking for right here is what number? That number right there. What number am I looking for? 6. Oh, right, wrong. There we go. So right here for A, what number am I going to plug in? I'm going to plug in a 6. Okay. All right. So here we go. If I went down, I'm going to go down right here. I've got a 4y times a negative 7y, and that gives me a negative 28y squared. That's how they got negative 28y squared. Because 4y times a negative 7y is a total of what? Negative 28y squared. You got one more. What am I starting with? 4y. What am I multiplying it by? I'm multiplying it by a b. And what is that going to equal? It's going to equal a negative 8y. So what we have to figure out is we have to figure out what number would go right here, right there, in order for it to equal a negative 8y. A negative 2, you're right. So think about it, ready? Watch this, I'm going to erase this. I'm going to erase that. And watch what I'm going to plug in. I'm going to plug in a what? Negative 2. 4y times a negative 2 is a negative 8y. It works. So what number am I going to plug in here? Negative 2. And that's what you guys are doing on this particular type of problem. Okay. A 6 and a negative 2. Now how do you check it? Here's how you check it. Is 4 times 6 24? Yes. Is 4 times a negative 2, 4y times a negative 2, negative 8y? Yes. And voila, you're done. Okay? So that's what you guys are doing on those problems. Good luck.